blockchain. It's capacity and anonymity. Capacity of blockchain is super important for you, I believe, because this is increasingly difficult to change data which is already in the conference call. You can't just call back and say, oh, geez, I'm sorry, I changed my mind. Because there are people who are constantly calling one after another, and every next register depends on the previous caller. But this is a natural limitations, because the number of calls of limited, and number of capacity, the resource to confirm the validity of calls is limited. In your case, just an example, it's very difficult to confirm, for example, a heartbeat, because, well, who would help me and say what is the normal heartbeat for a human being? 60/90. 60/90, perfectly. How do you think? What is the capacity of top blockchain systems like Bitcoin and Ethereum to confirm, like, per second, transactions per second? 10. Yeah, it's about that. It's about 10. So you cannot confirm like super minimal amounts of data. You better confirm something like something scalable, something big, like a disease. Unfortunately, I'm sorry, it's a negative example, but it's difficult to confirm little things with blockchain. And like a life hack for you, every time you're told that someday everyone will be buying coffee with Bitcoins, is probably lying to you, because like 10 cups of coffee per second in the world, that's a serious limitation on the humanity, I should say. But to compare things, Visa at least declares to serve about 24,000 transactions per second. So this is a whole different story. And another characteristic is anonymity. When I call and join that conference room, that conference call, the more data I give to you, the more validity you have when confirming that data. If I'm not introducing myself and I'm just like saying like my date of birth is this, it is the quality of data falls. But the anonymity allows me to give you that data. For example, if date of birth is not like a sensitive thing, but if we're talking about something which relates to your biology, genome, to your state of your health, for example, it is difficult to withhold it personally, right? So you don't want to give all your name, and you don't want your name to be associated with a particular disease. So the blockchain finds sort of a compromise where people can enter certain data, and they validate it on the entrance, and then everything is encrypted and maybe encrypted back, but it still can be traced back to you. So there is always a privacy issue with blockchain. All right, so good question. Still, the word of blockchain has multiple effects on economy today. It's just enough to mention it in your business plan, and probably your business prospects will rise tremendously. But we had a starting point that you have to understand the capacity, you have to understand the issue of privacy, and then you better address what problem are you looking to solve with a blockchain. So it is a general sense maybe that blockchain enters the world like equally everywhere. But that's not the truth exactly. It enters different industries, different areas of your life with different pace and with different effect. Most of us, I think, know about blockchain because of Bitcoin, and this is a very important thing, and you should probably focus on it, because Bitcoin is not penetrating the industry of healthcare or medicine or bioscience. Bitcoin enters particularly the industry of finance. There must be a reason to it, and to analyze it adequately, we should just ask one question: what problem is solved? What is the problem with intermediaries in finance, which caused that huge demand for Bitcoin today? This is very trivial. The highest spike in Bitcoin previously to 2017 was in 2013. Then Bitcoin gained fivefold very quickly against the background of the Greece bailout, when bank accounts in Cyprus were trimmed. Cyprus is one of the offshores having people who deal a lot with international relations and international economy understand that. So there is an increasing pressure in the world on the offshores. In the US, for example, where Apple pledged just recently to return $200 billion from offshores back to the home shores of the USA. In Russia, like a couple of years ago, the president signed a bill into law obliging and politely asking Russian businesses to reconsider their financial flows. So there is an increasing pressure on it, and there is a resistance to that from the people. So that's why people entered Bitcoin. That created liquidity and a lot of attention. That growth and interest to that phenomenon among general audience. But don't be confused. This is a very, very particular thing associated with how international financial flows are controlled. And of course, the second thing is the sanctions, which were imposed against the Russian Federation a couple of years ago. Again, like when you try to eliminate such a huge economy from global interaction, it creates for every action there is a reaction, and definitely Bitcoin seems right now like a reasonable alternative. When one of Russian senators was detained in France a couple of months ago for allegedly smuggling 700 million into the country. So definitely, if there was a way to change that, we would probably, as a country, reconsider the plans of smuggling those money or sending those money with the senator, and rather using Bitcoin transaction, which seems like a much more safer alternative, I think. So now we have to critically address the phenomenon of Bitcoin with all what we know already. And Bitcoin is definitely has made the biggest progress of all blockchain projects existing in the world. Let's think how Bitcoin stands against the advantages we listed in the very beginning. The advantages of transparency, the advantages of decentralization, the advantages of absence of any third parties or intermediaries in the way. In fact, the problem with Bitcoin is that there is no absolute freedom. If you take freedom, when Margaret Thatcher was visiting USSR and lecturing Mr. Gorbachev, she cited a very beautiful and phrase, which is definitely to the point here. If you take freedom, then you must take responsibility with it. And if there is no responsibility of intermediary, the responsibility falls on the shoulders of users. This means that if you are storing your money in the bank sort of accountable of what happens to your money. If you are taking freedom and you are storing your Bitcoins in your wallet, in your Bitcoin wallet, you're taking responsibility for keeping that secure. And a lot of users are not, as statistics shows, are not up to the mark with the responsibility they've taken. About 14% of Bitcoins were stolen. they're not stored somewhere. They're, of course, back in the system. It's but this is a huge amount of money. Not only people, but a lot of legal entities in the blockchain community are struggling with providing security for funds they store. The second thing is that we remember that blockchain is a decentralized system, but it happens that 8 out of 10 people in a conference call on Bitcoin are from China, which is sorry. Yeah, but this relates to the latest news that when there is the threat of regulation of mining, it appeared that China controls like a substantial part of verification of Bitcoin transactions, which is also weakly correlates with the notion of equality, independent decentralization. So there is a long way to go before we arrive at the proclaimed point of decentralization. The third thing is, and this is the direct quote from the founder of Waves, one of the biggest Russian blockchain platforms, Alex Ivanov. Like, consensus between the people matters much more than the technology. So that's it, folks. Right? We've tried to get a long way from the third-party intermediary, from human decision making, and here we are, like, where human decision making in the world of blockchain is now super important, and it manifests itself in a lot of forks, for example, which happens. I don't know how deeply involved you are into cryptocurrencies, but sometimes the opinions of decision makers in the system differ on how to write the second block, the second ring in the chain. And people divide the chains, and a fork is happening in the system. And Bitcoin has survived like a lot of them, and not only Bitcoin but Ethereum, like the third, I think, largest cryptocurrency, has also experienced that split into Ethereum and Ethereum Classic. When opinions of crucial decision makers split, it leads to technological consequences as well. So technology does not yet dictate the state of affairs in blockchain. People do. All right. So now with that luggage, I guess we're more or less ready to briefly touch upon the issue of initial coin offerings, and I think there's a lot of I cannot avoid this word hype around initial coin offerings in the world right now. And of course, people who involved in science, they may be a bit jealous about like millions and tens of millions and hundreds of millions of money generated in the ICO industry, drawn by different projects. I think the initial coin offering is when you promise to deliver a certain product, service, and you get money beforehand. So this is sort of a synergy between the Kickstarter and the blockchain. People pay insane amount of money for even high risk products, but although it's very, very controversial, it still works and it's still growing. So there is more and more money attracted through initial coin offerings, and it is, as statistics show, more money attracted in 2017, not by Bitcoin, but by altcoins, by other projects, less credible, less known. So on the one hand, yeah, people are much more risk hungry. They are ready to take more risks for super profits. On the other hand, a lot of non-blockchain projects entered the blockchain industry, and this is what I highly discourage you to do. People discovered that for example, not only digital services might be associated with tokens, like Bitcoin is a digital service, but also real material goods can be associated with tokens. And if you, for example, produce a bottled milk, if you produce cars, equipment, whatever, people all together started to get into the industry and buy their tokens of material goods along with digital ones. The argument goes that it still fits where the blockchain here. It still fits into the notion of a smart contract. A smart contract is a unique thing provided by blockchain when two, for example, conditions in the blockchain met. When we agree beforehand that I call into the conference room and I say that, for example, I need a car to be delivered in 3 months, let's say, and I'm ready to pay X amount of money for that. And then, if in 3 months my counter agent calls in the same conference room and says, like, remember that call by Elijah 3 months ago? The car is ready. You may pick it up. So the algorithm sees that on the one hand, I've provided the money. On the other hand, the car is provided. Then the contract is fulfilled. There is very little necessity for blockchain here, unfortunately, which sort of I think discourages and sort of affects in a bad way the philosophy of blockchain, at least. But still, the biggest it is very interesting to watch how people make decisions in that situation. For example, there are 2 ways to go about tokens. One is a security token that all of those cryptocurrencies which rising 100-folds in a day. These are tokens which only give you right for the profits, mainly give you right for the profits of the company. So they are not associated with a particular service or good. On the other hand, utility tokens, they never give you super profits. This is like a modest way of addressing ICOs. Utility tokens are constantly associated with a delivered good or service. So, for example, if you are a car manufacturing company and you choose your token to be a security token, just freely tradable, you may, for example, experience like a 100-fold rise in the stock price because people like believe in your super project on the concept car. But if that's in a utility token and you like sell a certain one car with one token, there is no way you will get super profits there, and you take responsibility. So this is a very different thing. If you are issuing an utility token, you are taking responsibility to produce a certain good. If you are issuing like a security token, like freely tradable, people take responsibility for them, that take the risk that you will produce nothing. And the industry shows us that most of the people prefer to take the risk rather than the car. That's how it works, at least. If we zoom into the like science, medicine, healthcare industry, a rational thing to go about an ICO would be, for example, to produce a certain drug and collect money from people. You will not hear many stories like that. There is a number of reasons for that. Number one is responsibility. It is very difficult. 90% of projects which go in ICO is basically a pledge to produce an app. That's it, like maybe a website, a landing page with certain functionality. This is something different. I'm trying to be very respectful about the job you do. I understand that to produce a drug is not to produce an application. With all due respect for developers, these things differ. And to produce a drug, it takes a lot of testing, a lot of parties involved, and those parties which are involved, they normally have enough funding on their sides. And the second thing here is that it is clearly a problem of overregulation of medical and healthcare industries. These are very conservative spheres, and it is difficult to produce a designer drug for particularly regulating issues. I believe. Okay. So I've collected some of the examples of companies which do relate to the areas of healthcare, medicine, bioscience, chemistry. Most of them reside on either collaborative research, intellectual rights, or patents verifications, or machine learning on personal health data. I think the latest collaborative research is more or less simple. It works like you upload the results of your research in the blockchain, and it prevents further researchers from duplicating the work you do. So this is a very understandable and and working method of collaboration, if there would be enough collaboration at all in the world. So if certain universities agree to establish a common blockchain, that would create a synergy. But it takes a lot of work before the blockchain is established. A lot of negotiations, a lot of trust between the parties in the first place to join their forces in certain research. Intellectual rights and patents, that's more or less simple. Then you see which that a certain drug or a certain scientific breakthrough is associated with a certain party. The patent is taken, and you may reconfigure and not continue research in the same direction. And then machine learning and personal health data. This is this resides on utility tokens. When people are given tokens in exchange for their data. This is an interesting model which allows to attract a lot of data into the system, and that data gets analyzed. This may be personal health records. This may be even genome. I think the next speaker would elaborate on that topic. And then the data gets analyzed by a certain algorithm or a neural network, and in exchange, people would get medical recommendations, personal healthcare recommendations, consultancy, etc. The thing is, it is a very sensitive thing, and very difficult to elaborate from public policy standpoint of view, because it is common knowledge that data is much more precious, much more valuable than the algorithm which analyzes it. Like many machine learning and artificial intelligence algorithms, they are provided for free by the industry leaders on Google, but no data is provided for free. So people have to be very mindful here, and I think they are, and a lot will depend on the first results of the projects which work on this model of cooperation with a broad range of people who are ready to submit their data in exchange for certain recommendations. Yeah, I think so. The biggest, however, philosophic issue here, I think, about on the interaction point of medicine, of biology, and blockchain is whether it's a breakthrough or not. let's hope that blockchain is not a revolution. Let's hope that it is a breakthrough. There is, it's a bit speculative, but there is a difference which can be formulated in a quote by Mr. Ford, the founder of the Ford Corporation, when he was asked, like, why didn't he ask, like, people and what would be the next step? Like, why did he take the risk all by himself and produce, like, the metal car, massively produced a car instead of a horse for people? So Henry Ford answered that if I would ask people, like, what they needed from me back in the day, they would say a faster horse. They would never say I want a car, right? This is, and I can assure you that blockchain is a faster horse. That it is not yet a car, because, like, 99% of pitches you will be reading if you get to deal with blockchain would say 5 to 20% efficiency. So blockchain, that verified, secure, and encrypted database, allows to increase efficiency, to battle duplications, to battle fraud, to battle many things, and that would be about 5 to 20% increase in efficiency. Like, if all the data which is in the system is accurate. The thing is here, so this is definitely making a horse faster. The thing is here, if you really want it, again, the whole talk here is all about responsibility, because in that 5 to 20% gray zone belong a lot of things. For example, yes, for one, let's say for 10 million of stolen money from healthcare healthcare insurance, there would be $1,000 or maybe $2,000 when a doctor makes a deliberate decision for himself to take on a case which no one else would, because this is a really difficult, and I don't think you would want to live in a world when you'll see a patient coming up with like cancer stage 4, and you'd say, like, yeah, sorry, it's in your blockchain. You don't want the blockchain to be taking decision entirely, to be substituting yourself. So I wish you very mindful, very responsible approach to slowly, gradually integrating blockchain in your everyday work, if you did it. I wish you all the best of luck here, and thank you for having me.
Thank you. And the questions? Okay. The audience needs some time to make the all information for themselves. But still, Elijah will be here for a couple of days, and you can come to him and to get more detailed information.
I'm here at your disposal. Thank you.
Yeah, thank you once more. And now we'll have a 15 minutes break, and we'll continue here.
Да, конечно.
Okay, guys, we have a short break, just 10 to 15 minutes, and then we will go back with the application, with the lecture about application of blockchain to genomic data. Hey, hello guys again. All the guys in each Good Game YouTube package. Привет, ребят, всем, кто нас сейчас смотрит. So I want to remind you that it's an online translation, not a pre-recorded video. It's online translation from our Future Biotech Winter Retreat, dedicated to IT, medicine, and biotechnology, and biology at all. So the next speaker, let me announce it for you. Just give me a second, I'll open our program. So the next speaker will be Vladimir Naumov from Zenome company, and he is a genomic data scientist, and he will have his presentation about the Zenome project, blockchain-based genomic ecosystem. And I want to also remind you that you are free to ask questions in the chat. I'm very carefully reading YouTube, Twitch, package, and Good Game, and I can also translate your questions to the speaker. So please feel free to ask any question on the topic of the lecture. And also, hi. So this is, as I've already said, it's an online translation. It's a stream from our winter retreat. We are now in the Sochi. It's a town near the coast of the Black Sea in Russia. And through the whole week, we will have many top scientists, top world scientists, who will perform the lections for our participants, and some of them will be streamed to our channel. So if you're not a subscriber of any of our channels, so subscribe to not to visit all these streams. There will be lectures about different software solutions in molecular modeling, in biochemistry. There will be lectures about biology at all, molecular biology especially, and all other applications of IT in medicine and biology, because that's this is the main subject of this winter retreat. Also, let me thank all the guys who participated in the organization, including our partners. You can now see them on the slide. It's top Russian and international companies in the biology and biotechnology field, and also like Biotech, like Helicon and Genotech. Also, we want to thank our partners like British Council, who helped us a lot, especially with inviting some speakers. Also, one of the coolest partners is Tech, or Skolkovo Technological University, and our info partner Biomolecular. It's I think it's best Russian popular scientific site, biomolecular.ru. And also, I want to thank our moderators in chat. Thank you, Lila. So we will continue just in a few minutes, so please stay tuned. Meanwhile, let me tell you some words about our project called Future Biotech Live. So we started streaming 2 years ago on Winter School, on Future Biotech Winter School 2016, and we are trying to deliver the best science for you in the web. We stream lectures of top scientists, top world scientists, even Nobel lectures. We stream from laboratories how real scientists work, especially young scientists in their own labs. And also we have a popular scientific show called Science for Breakfast, where we discuss all the latest news in the field of, let's say, high science. So we discuss papers from Science, Nature, Cell journals. Okay, and I think we are going to start just in a few seconds. Okay, 10 minutes. 10 minutes. Oh, yep. Okay, so we have 10 minutes to speak with you. And now I will have several messages for our Russian-speaking viewers. Привет, ребята! Всем еще раз. Привет, Дис, привет, привет, Владимир. Привет, Киля, привет, Татьяна Малыгина. Привет, Елена Былкова. Привет, Филипп Джей Фрай. Так, вроде со всеми поздоровался. Привет, Куки Монстр. В общем, всю неделю мы будем для вас стримить лекции с нашей замечательной школы. Поэтому не пропускайте, подписывайтесь и смотрите. Стволовые клетки тоже будут. Телемедицина будет и блокчейн будет. Кстати, про телемедицину будут рассказывать в том числе ребята из сервиса Яндекс.Здоровья. So, if you'll check the program, you will find entrepreneurs, CTO, CEOs of different software companies, including Yandex Health Startup. It's a daughter company of Yandex, very well-known Russian IT giant. Let's say it's something like Russian Google. Привет, Анастасия Кирик. So, and also, if you're here in the first time, usually our streams are dual language, but the working language of this conference is English, so all the lectures are performed in English. So that's how it is, and I hope if you didn't have enough practice in English, it's a very good opportunity for you to practice more, way more in English. And now Lila or Natalia Vedma linked our program, so you can see who will participate in our conference as a speaker, just in case if you're interested. I hope everything is okay. So we from time to time we have some troubles with the internet, so sorry in advance, but we are trying to do our best. And if you have any comments about sound or video, please feel free to post it and I will try to fix it as fast as I can. Okay, so we will start with another lecture by Vladimir Naumov. So it's a lecture about his project Zenome, and this is a blockchain-based genomic ecosystem. And you know, we have this kind of let's say blockchain evening. So the previous lecture was by Elijah Glazunov, and he told us about how different blockchain technologies can be applied to different parts to different parts of our life in different technology industries. And you can we also will upload those lectures which we do not stream. We will upload them later to our YouTube channel, and records of the stream will be deposited on our YouTube channel, so you can watch them later if you want. Okay, so we will start in a couple of minutes. Stay tuned. Привет, Помежits. Привет, Mindfrag. Okay, guys, I want to tell you that we will start just in a couple of minutes. We are on timing, so but you know, because it's an offline event, we have some breaks, coffee breaks, and meanwhile I can show you the audience here, young scientists. Oh, sorry, not, yep, like this. So these are young scientists who filled their applications and were selected to participate in this winter school. They're best of the best. They publish papers, they participate in international conferences. They do very really cool science. So you can see this lovely place. We have many guys. We have 62 participants, as far as I remember. Yep, lectures will be only in English, because the working language of our winter retreat is English, because we have many foreign speakers who are top scientists in their fields. So we've decided to stick with English. Mindfrag, as I already said, it's a very good opportunity for you to practice.
Okay, we're continuing our day. So, and we're continuing the topic of blockchain technologies, and I'm pleased to welcome here Vladimir Naumov, who will speak about Zenome platform project. Please.
Good evening, ladies and gentlemen. I'm really very glad to be here to talk to you about Zenome platform that I'm developing with my colleagues, and I'm very happy that two previous talks were somehow interconnected with the things I will tell you. And I also have to sorry for my not so good English, because I studied German at school, but I'll try to do all my best to explain you all this stuff. Let's start. Welcome to the genomic revolution. That's what our advisor, Richard Reznik, says, and that's his topic on his TED Talk that had several millions of views, and he's now helping us. And most of my talk today will be about genomics, genomics data, and how to use it, and how we can use it to get something new for our society. So genome is the entire set of genetic instructions found in any organism cell. Most things I will say today will be about human genome, and there is also an interesting citation here. It's about that genome is like all our instructions in a digital form. So let's go to the plan. First, we'll talk about genomics, then about the genomic market, about possible application of the genomics, about some challenges that we have. Then I'll explain our solution in that field. Also some challenges that we have. Then I'll do the real talk about token sale, that interesting questions, and we have now practice in it, and I can share it with you. Also, I'll show you what we have done after the pre-sale, our minimal product that is useful now, and so on. Let's start what we can do having the human genome. First thing, to get it, it is cheaper and cheaper every year. I'll have a special slide for this. So if we have someone's genome, we can get a lot of information about the person. We can get info about how you looks, your ancestry, possible diseases, best diet. We can also exclude some allergens that are probably bad for you, and predisposition to different types of addictions. It's all possible because modern genomic technologies are getting cheaper and cheaper, And also there is a lot of genome-wide association studies or some other kind of studies that can bind difference in genomes to difference in phenotypes. There are also a lot of other applications, not only getting the genetic report for a person. For example, when we speak about science, we can study new ways to produce drugs, new ways to cure diseases, and also find something new about human ancestry, and so on. There's also a bigger and bigger interest to genomics from big pharma companies, e-commerce companies, and companies who produces different goods. They're trying to use genomics to do it more specific for a person using his genome. Now let's talk what's going on with the genomics market. It is growing very fast, faster than other areas of and it will be about $60 billion in 2020. And it's growing even faster than this prognosis that's shown here. And why is it possible? Because the getting genomic information of an individual is getting cheaper every year. It's getting cheaper faster than the Moore's law. I can show it here. Maybe you saw the picture several times. And also the market is growing. There are different technologies that allow us to get person's genetic information. It can be divided into genotyping, that can get only several genetic points from human genome, to sequencing, that can get some parts of the genome, from small genetic panels to the whole genome. It also differs in the price, and here are listed the companies who is doing different kinds of analysis, from DNA microarray analysis from companies like 23andMe till the whole genome sequencing that can be done at BGI or Human Longevity Alliance. Here are listed the main companies who provided genetic testing. The biggest of them is the 23andMe, who has about 2 million users. And all these users got the genetic data. And what's also interesting is that 23andMe gives the test results for very low price. It's about $99 for a moment. And why is it possible? I will show you this thing, because when you give them your DNA, they're reading it, storing and getting your genomic information, giving you back some small report with several types of even non-diseases, but just like we call it genetics for fun. Some ancestry, some dietary recommendations, and some sports recommendations. And what they get from you is your whole genomic information and also a lot of phenotypic information. And now there is a lot of information that they sell it to big pharma companies and earn really big money, so they can give you the genetic test very cheap, but earn money from your data. And what we wanted to do is to change that paradigm and allow people earn money from their genomes. Because your genome with your phenotypic data is really very expensive data set that can be used to produce new things. And what's going on in field of genomics in the scientific community? There is a lot of different initiatives. The most known is maybe 1,000 Genomes, who is sequencing genomes of different populations all around the world. And there are a lot of smaller and bigger projects, but they all are very divided and not connected to each other. And there are also some initiatives that are trying to collect all that information in one place. One of them is EXEC, but they have some privacy issues. Like I'll tell you now that genomic data is also very sensitive because when we, for example, have someone's genome in a form of text file, and we don't know who is that person. We can get a lot of information about him. First, we can find out the gender of the person, of course, by chromosomes. Then we can find out how it looks, how he or she looks, his face and voice, what was shown by Craig Venter last year. We can also find out the possible height, weight, and body mass index, also eye color and skin color. So it's almost possible to find who is it. And why is it not so good for you? Because it is possible to find what inherited disease does person have, what addictions he has, and also in genome you have all the information about your donor compatibility. So if someone has found you using your genomic information and he has your donor compatibility to some bad guys, they can hunt you to find your kidney and to get it. Maybe that's just a predisposition, but maybe it can happen in our crazy world. So we decided to do this blockchain-based genomic ecosystem, and I'll answer your maybe question that if we're going to store genomic data on a blockchain, the answer is not, we are not going. The blockchain is needed here for the transparency, and I'll explain you the scheme a little bit later. So our solution is based on the next paradigm. We have genetic data that will be stored on a distributed hash table network, and genomic information will be fragmented and distributed. So no one can find the whole person's genome. So it will be secure and safety to store it. But if someone wants to share some parts of his genome to the community, scientific community, or some company to get genomic-based services, it will be possible. All the transactions here will be stored in an Ethereum blockchain, and also Ethereum blockchain will contain a rating system that will rate users, companies, and service providers. So they all will be able to interconnect and know who is going to get whose information. And one more part of data is personal data. So if person has his or her genome and he wants to earn money from it, you can fill the questionnaire and tell some of your phenotyping variables that will be useful by company to create a new genomic product. This is the whole system. The schema is really a little bit crazy, so I'll try to explain it in a simple language by using 4 base system roles. These roles are scientific community, person like me and you, data consumer, and service provider. So who is going to do what? Let's start with the scientific community. I don't know why our designer added his guy to the slide, but the scientific community wants to get population frequencies to understand. It's just because I want to explain all this really easy and very transparent. You can ask any kind of questions. So we are going to create an API, and when the user uploads his data and wants to store it for free, he must be able to share some non-sensitive information to the scientific community. For example, when someone is doing exomic analysis of person who isn't healthy and is trying to find out is the variant is disease causing or not, he will be able to use our API to screen through all the genomes that are in the system to find out is it really low frequency variant, or maybe in some population it's it can be often found. For person like me and you, it's possibility to get new genomic based services like dating services, personal diet, training services, and a lot of others like Andrew told today, this Zenome. And it's getting more and more companies who are trying to use genomic data to give the new services. And our platform is going to make it easier and more secure, because you don't need to each time give you saliva or other specimens to the company for they could get your DNA. You will be able to just, like you pay now with our smartphone, you will be able to give the part of your genomic information to the companies. So we are going to create the market of different companies around the genomic information. For data consumers, I'll explain what is it now. Last year, our team worked with Unilever company on some very interesting project. So Unilever is creating a marmite. It's a pasta with very interesting flavor. It's interesting because half of UK populations love it and half of them hate it. So we have done genomic-wide association study and found about 15 markers that are predisposing you to love or hate it. And what's next is Unilever can use this 15 marker panel to look into population data, for example, in Southern Genome Project, and to find out in which country it will be possible to sell this marmite without any changes, and which country citizens will hate it, and they need to change the flavor of the pest to sell it there. And it's getting more and more examples of such interactions between genome and services and products. And of course, service providers that are very, there's a lot of them now, and we hope that they will also join our community, because they will be able to give their reports and they will compete between each other. So it will be cheaper and better reports for humans. We solved some issues that can be here. First is we are going to store a large volume of genomic information by storing the data on the decentralized network. I will tell it once again, we are not going to store it in a blockchain because it's not so fast and it just won't be able to store these large amounts of genomic data. We are going to prevent possible misuses of the platform by implementing rating system. So everyone on the platform will have his rating. A service provider, a person, a scientific company, and so on. Also, we are going to make genomic data accessible by scientific community, and we are going to build a market for genomic data exchange. But the person will decide which part of the genome it can share or it can share. And each time someone signs that he is going to share this part of the data, we will tell him if it is safety or not. Because people not always know what genomic data is sensitive and what isn't. For example, when we speak about these Ashelia haplotypes that can be used for donorship. This is how it will work. So the user sends his or her genetic samples to accredited partner labs. Then he receives a text file with genetic sequencing results, uploads it to the Zenome platform, and then he can order analysis of his genetic data, or he can sell his genetic data combined with phenotypic data to different companies who is interested in it. Now let me show you our team. Most of the guys with me are working in the field of biology. We also have a blockchain developer, and that's our advisors, Dmitry Kwon, Yuri Nikolsky, and Richard Reznik. Now let me tell you what was the pre-sale. So in the system that were the tokens, DNA tokens, we're going to use it like utility tokens inside the system. And because we needed some funds to create the project, we started the pre-sale about 2 months ago. And what we understood that it's a really very easy and good way to get funding from the crypto community if you have an interesting idea. Because you don't have to wait too long. Also, you can find early adopters of your system, and also the people who invested something into it will be interested and will be pushing you to create the project faster and better. So what we have learned is that our world now is so good interconnected that if you see someone on the TED or on the YouTube and want to contact that person, you can just write an email, and usually they answer us and helped us. Also, when we started the project, the people from different press websites contact us and wrote a lot of papers about us. I'll show you on the next slide. We are really proud of our papers. And also, what we saw the last time, if the idea is cool enough, there comes the new competitors to the field. So last month, the guys who previously worked on Illumina, that big sequencing company, have published the white paper with the same idea like ours. It's called Luna DNA, but we are a little bit forwarder because we have a small product, like minimal product. I'll show you now what it does. And that's our press. That's how can you find, if you just Google Zenome, you will find a lot of papers. Our roadmap, and we are now here, is we are going to do the MVP, then the pilot version, then the Zenome Fund, and get some lab partners. We also have talked to several labs in the Moscow, and they are now going to be our service providers and partners in getting genomic information. So by the end of the year, we hope to create the market and get the first big pharma partners. And what's now, we have the market of genomic data and services. We have an MVP where you can upload your data now from 23andMe. You can also fill the questionnaires and get the first report from service provider through API. That's really basics. And we have now growing interest to the project. And the first step of our big token sale will start on 1st February this year in several days. Now let me show you the video with our minimal product. Oh, sorry. I'll tell you what's going on. So that's just the intro. First, you have to go to our GitHub repository and download the appropriate version. Unzip it. It's just a video. Then open. Create a new person. It's really easy. Then just click on it. Here you can fill something about your phenotype, like your eye color and some other different parameters. You can also fill the questionnaires that are provided by laboratories about your health, so on. And you can also upload a 23andMe file. And now 23andMe has 2 million users, and some of them wants to use it. You can browse your genome, this table, and get a report. We have a company called Rosalind, and it can provide you a report about vitamins and minerals. So how it looks. Now this is only the part of the product, but it works. And I want to thank you. I want you to, if you have some folks, you can share it with us, connect on different web services. And thank you so much for your attention.
Thank you. So, any questions?
Thank you for the talk. And what about the verification of phenotype data? I understand how you can verify genome data, but how can you verify how the user do his test, анкета?
Okay. How is going on? It depends on the data they need to provide. For example, if it's some physical activities, it is possible to control it to the camera of the smartphone. For example, eye color or something like this. If this is some flavor, for example, a beer producing company wants to test if their new product has a really good test for someone or bad test for someone else, then they can create some centers where people can come and test it. Also, so some difficult phenotypic things will be controlled by specialists like doctor, and some easy phenotypic tests will be controlled easy, and also each person will have the rating based on previous research, so we will understand who is trusted and who isn't. Yes, it's difficult.
Thank you. Any more questions?
So, are there any legislation like which controls your activity, like laws, something? Because, for example, if I will register at your platform, submit my genomic information, then I will sell it to some company, and then like, do I still retain my rights on this data, or the company that bought it, like, and how it can be controlled?
As I will answer, you are always the owner of your genomic information. You can just share some combination of your genome, and so you are allowing to use it for only one study of the company, like this, and then they can't use it in the other ways.
Thank you. Do you want to use genome of person for your project? Yes.
Yep.
What do you think about the security of genomic data of the person who will buy your product?
Just person who wants to get genomic services, who also has his or her genome. For example, from 23andMe, as we know now, 10 million people have their genomic data somewhere, for example, on their computers. And of course, it depends on the products that are on the market. For example, the fitness centers who can use your genomic data for better training program, or maybe some food delivery systems who is going to give you the food that it's best for your genome, or some other.
No. I'm about genomic data. For example, if any hackers can hack the server with genomic data, and this information can be published.
So it's impossible, because this is how we store the genomic data in these distributed hash tables. We divide the genome of the person into small parts, and the file that has the combination of all the parts and knows on which node each part is stored is only on person's computer. So if someone's computer will be hacked, then his genome will be hacked. But it's everywhere, so.
Okay,
like
thank you.
Like the previous lecturer told, it will be on the person's, so it will be on the person.
Thank you.
Thank you. So if I understood well, by now I need to upload my own genomic information to your service. But
Yes.
as you continue to progress and to develop, the sequencing will be provided for free and or not?
So maybe we have a scenario where someone will be interested in your personal genome so much that they will give give you money to get your genomic information, and then maybe you will be able to use it to get some reports, but they will own it from this moment. If not you upload it, but some company, we think that there will be some pools of genomes. For example, there is a country that is interesting for companies who wants to get genomic information, but people can't do genomic analysis by themselves. So then the company will create a pool and will have it on the system and will somehow sell this genomic information.
But the person whose genome it is won't own this information anymore.
Yes.
So it would be the rights will be on the company that will perform the sequencing. Yeah.
Sure.
Okay. So, but as I understood, the idea is to provide this discount for people to have possibility to sequence their genome more cheap than just to go.
That's also the idea, but how it will be go on, we don't know.
Okay, thank you.
Okay, one more.
Hi. You've mentioned this software by Craig Venters, the face prediction software.
Yes.
But in scientific community, it faced a lot of criticism because even some co-authors said that it doesn't work like that. Because
no, he didn't say it. I know the story very well. It was the long story on the bioarchive where one guy wrote that it's not working, but then the Craig Venter answered. And so anyway, this is only an example where they used the really not so big sample. It was only 100 samples, but they was able to predict faces, voices, and skin tones.
As I remember the story, the problem was that images, the 3D images of faces were so general, they based more like on a race of a person, not about his genome. So in one degree, how we see that face, that anyone's face with this gender and this race, that can be somehow be composed. So
yes, I also heard that arguments, but it was also the next step in that discussion. And as I know, in final, it was they say that it works.
Okay.
Good evening. Thank you for your lecture. And will it be possible to find a person by a part of his genome? So, for example, you will get a pharmaceutical company a sequence of first chromosome, and it will be a lot of sequences from different persons, but one sequence is very interesting, and the pharmaceutical company want to know who was this person, or maybe not pharmaceutical company, or other guys.
Okay.
Thank you.
So is this possible or not?
Yeah.
So we are trying to do everything for it. It was impossible, yes, because the genome will be will be divided into so small parts that it won't be any interconnection. Because if you have only one SNP, it's almost impossible to find the person. If you have several SNPs, it becomes possible. As I know, about 52 SNPs on different chromosomes with frequency on the population about 50% will be enough to identify any one of us. But only one SNP won't, it isn't possible to do. And we will do everything to, the company could get only one SNP from the person. Like, they won't get the connection. Yes, we will leave the information that we gave, so it won't be impossible to find the person.
Okay, let's thank Vladimir once more. And now we have a break for dinner, and we'll meet here back at 19 o'clock for the evening session. And one more information, the next QR code checking will be tomorrow before morning lecture.
Okay, hello guys again. Hi. So my name is Arthur, and I'm director of the Future Biotech Live project, and we will be performing online translation from our winter retreat called Future Biotech Winter Retreat 2018, and dedicated to molecular biology, medicine, and IT in medicine, the role of IT in medicine and molecular biology, and so on. So I'm really happy to see so many guys of you in the chat, on YouTube, on Twitch, on Package, and Good Game. And so none of you used this unique opportunity to ask speakers. So because I'm reading chat and I try to read it very carefully, you can ask your questions in the chat and I will transfer them to the speakers. And okay, in the last time we also had a friend of speaker, Nikolai Kolemin, on YouTube, and he's also a part of Zenome project. So you can also ask him about any questions about this very beautiful project. Okay, so I think that for today it's all. We had 2 lectures dedicated to blockchain and its role for any other application and its application in biology or in medicine. So if you're interested, you can check the program of the whole school. I hope Lila will post it in every platform, so you can watch our streams. We'll stream, as I already said, every day, usually after so in the second part of the day on the Moscow time. Okay, and let me announce the streams for tomorrow. So tomorrow we will have Okay. So tomorrow we will start at at 16:30 at the Moscow time, and we will have a round table called Career of a Young Scientist, Key Competences and Important Features. So because it will be a round table, there will be, I hope, very hot discussion, because it's a very important topic, especially for young scientists who are participating in this school. So some of you told that there are only 3.5 guys in the room, in the hall. So I will argue, because we have 62 participants from all over Russia. So they are students of top Russian universities, or they are employees of top Russian companies. They are young scientists from top Russian universities and scientific institutions. And we have lectures from all over the world. Among them, top scientists. There are CEOs of pharmaceutical companies or other representatives of, like, for example, from tomorrow we will have a lecture from Schrödinger, from employee of Schrödinger LLC, a very well-known company in the molecular biology field. They, for example, develop my best loved application called PyMol for 3D visualization of biological molecules. Okay, so I do not see any questions in the chat. So okay, again, hello guys all. Hello, Iron Flag Strikes Back. Hello, Perchik. Hello, Medved Pedabir, Brigadier, and all other cool guys and girls in all the chats. So, okay. Also, you may have noticed that we have an Alexander Panchin here at the school, and he will also have a lecture, but it will be on Thursday, and it will. So, this lecture is titled "Time Traveling Porn and Other Signs of Reproducibility Apocalypse." So I hope this lecture will be very cool, and it will be popular science lecture. So you're not required to have any special knowledge in molecular biology, but it would be better if you do. Okay, Head, I will remember your advice. Oh, okay, so there is a very hot discussion about Zenome project. They are just right in front of me while I talking with you guys. So I think this is all. Thank you all for watching. Thank you all for having us. So subscribe us on YouTube, on Twitch, Package, Good Game, and any other platform. And any other platform where you watch us, and also subscribe to our social networks. We have a Facebook account called Future Biotech. We also have a contact account also with the same name, Future Biotech, Telegram, and Discord. So if you do not want to miss any future stream, subscribe and you will get a notification. Okay, I see many comments. Lord Zeratul, I'm not really special in this field, but I will ask some participants of this school, because I think that there are maybe several of them who works with the cryoconservation of different biological tissues, including sperm. And they will advise you something, and I will write you later. Okay, so I do not see any further questions. So again, thank you for having us, and goodbye until tomorrow. So we will have streams, and the last announcement. So we still in the process of making decision whether we will have tomorrow a Science for Breakfast stream or not, because we have a very complex technical setup here in the main hall, and we will have to set up another point for stream, and I think it would be not so easy for us, but we will try to do our best. Okay, so goodbye.